Okay, so today we're going to learn how to do an independent sample t-test in SPSS. So make sure your data is on the desktop. Your SPSS data file is on the desktop, and then click on the file so that your data file then opens up. You can do this either from data view or variable view. It really doesn't matter. Remember, when opening up a new data file, always go to the variable view tab and take a look at the different variables in there, and specifically the values, so that you know, like in this case, gender. When you click on the values that's adjacent to gender and you click on the little blue button, it'll tell you the coding: 0 for male, 1 for female. The other way to do it also is to do a code book, which we've gone over before in SPSS, which would be display data file information that you can find under the file command in the top menu, display data file information. And this will give you a code book so you understand what the codes are. So we're going to do an independent sample t-test, and we're going to take a look at and see if there's a significant difference in the mean scores. Oh, I have the wrong file up here. Here's the file I want. In the mean scores on SAT math based on gender. Do males score significantly different on SAT math? So to do an independent sample t-test, the first thing we do is we click on the command Analyze. Pop-up window appears. We want to go down and select Compare Means. When you do that, another pop-up window appears. Scroll over and select Independent Sample t-test. When you click on that, another window appears. On the left side are all the variables in your data file, and on the right side is what we're going to tell SPSS to do. So our test variable, or our dependent variable, is going to be SAT Math. So we look through our variables on the left-hand side, select SAT Math by clicking on it, then clicking the arrow between the two panes, and SAT Math will pop in there. Now we want to look to see if there's significant differences based on if there's a significant differences on the SAT Math mean score between genders. So we select gender, and we put gender into the grouping variable box. Now you'll notice once I put gender into the grouping variable box, the label gender appears, but also what appears are two little question marks. In other words, SPSS doesn't know what this specifically is, so we have to define this. So you click the Define button, and you'll see another window pop up, and it'll say Group 1 and Group 2. This is where we put in our codes for gender. And it's arbitrary, it really doesn't matter, but you have to use the correct codes. Gender is a dichotomous variable, and we coded it 0 for males and 1 for females. So in the Group 1 box, I'm going to type in 0 for males, and in the Group 2 box, I'm going to type in 1 for females, and then just simply click Continue. Once I've defined the groups, I'm ready to go, and I click the OK button. The t-test, the independent sample t-test, is then calculated on the mean SAT math scores for males and females. The first table that we see are the group statistics, and it says there are 34 males in this sample, or in this data set, and those 34 males had a mean SAT math score of 516 with a standard deviation of 99. The females, there were 41 in the group, had a mean SAT of 469 with a standard deviation of 85. So we already see that there's a difference here, right, between males and females on the SAT math. But is that difference significant? So the next table obviously tells us is the independent sample t-test table. So the first thing we look at is this Levine's test for equality of variances. Now what this tells us is, are the variances in both samples, the males and the females, basically equal? That there aren't extreme scores on either end that is basically creating a non-normality of distribution of the scores, which we don't want because that's an assumption that has to be made for an independent sample t-test. It's assumed that the variances or the variability of scores for each sample are basically equal. So SPSS runs a test for us called the Levene's test. We don't have to do anything. It actually will run it when we run an independent sample t-test. And what we're looking for with the Levene's test for equality variance is that the difference or the variances for both groups are equal. So we do not want a significant finding for Levene. This is one of the times when we're doing statistics that we don't want to see a statistically significant finding or statistically significant difference. What this is telling us is that the equal variances are assumed. Consequently, we would read the data in the top row, okay? If we had gotten a significant Levene test, if it had been significant, no need to worry. What happens then, as you'll see down here, it says equal variance is not assumed, meaning that we got a significant difference. If that were the case, we would read the data in the second row, which very often is similar. So again, we look at if the equal variances are assumed, as in this case they are, we read the data for the top row. So what do we have? Well, we have a t-statistic of 2.193, so it's a fairly large t at 73 degrees of freedom. And are the differences in male and female mean scores, is that difference significantly different? And the significant two-tailed tells us, yes, it is. The significant two-tailed is 0.03, which is less than 0.05, so that is a significant difference. What is the difference? Well, we look over to this cell, and the difference between the males and the females is 46 points. So males do score significantly higher than females on the SAT math score. We go over to our 95% confidence interval, and what this is saying is that I'm 95% confident that the actual difference in the male mean score and the female mean score, the actual mean difference for the entire population of males and females on SAT math is somewhere between 4.2 and 89.5, which is a pretty large range. So that's how you run an independent sample t-test, and that's how you interpret the table.